let's have a look at question 13 now. So question 13 is very much an exam style question. So things like this is what we love to put in exams, okay? So it's really good that we can go through this. So you know that you always have a lot of prove or show questions in exams. So in this one, we want to show that the differentiation of tan cubed x equals to this, okay? And how we do this is always start off with one side and work it through until it looks like the other side. So start off with this side, and what I want to do is split that into tan squared x and tan x, and that's because I want to make this into sec essentially, yeah? And I can't do that if it's cubed, but I can do that if it's squared or just tan by itself. So with this, I want to find the differentiation of this. Because I've separated it, I now need to use the product rule. So remember, the product rule is to take the first one, find the derivative of that, times the second, plus the first times the derivative of the second, okay? Now, let's work out, firstly, what the derivative of tan squared x is. So it's told you what it is here, but I'll show you why that is. So tan squared x is essentially the same as tan x, the whole thing squared. So if I want to find the derivative of that, it's just going to be the chain rule. So I can take the 2 down, yeah? And because subtract from that, so that'll just be tan x there, but I need to multiply by the derivative of this, and the derivative of that is just sec squared x, okay? So that's why the derivative of this just equals to 2 tan x sec squared x, yeah? Okay, and the other thing is the derivative of tan x just becomes sec squared x. Now, on your standard integral formula sheet, you'll see that the integration of this equals to that, yeah? So you can work out from that the derivative of tan x equals to sec squared as well. All right, so this is how we get this equals to 2 sec squared tan x multiplied by tan x. This becomes just sec squared x. So if you multiply that all together, this becomes 2 sec squared x tan squared x, whereas this is going to be tan squared x sec squared x. So both have sec squared and tan squared, so essentially I can put them together. So that just gives me 3 sec squared x tan squared x, which you can see it's getting there, you know? It's kind of getting similar, but not quite yet. We still need to get rid of this tan squared x, and how can we do that? That's right, we're going to have to use our trigonometric property where we know that sec squared x, remember this, equals to tan squared x plus 1. Yeah, so we have to use this, move the 1 over, and change it to that. Now I just need to expand that. So this becomes 3 times sec to the power of 4x, and that'll be minus 3 sec squared x. And you can see that finally we have gotten it to equal exactly that, yeah? So this was a difficult question, so let's just quickly have a little rerun of it. We just separated this into tan squared x and x, product rule, and using this, the chain rule, we worked out that the derivative of that was this, yeah? And then finally, we also needed to use our trigonometric property up here. So you can see in this one as well, there was a couple of trigonometry tricks that we needed to pull out to work out the answer for. All right, so like I said, very similar to exam question, and that's because we have part A and we're gonna have part B as well then. And part B is gonna be related. So after showing that, it says, hence evaluate sec to the power of 4x, integration of that. So if it says hence evaluate, you know you're gonna have to use part A, okay? It's a very good clue if you see hence there. So in part A, we worked this out. And now I just want the integration of that, essentially, yeah? So that means I want this on one side and everything else on the other. So that's just all I've done. I've just moved that to this side and everything else to the other. And we have this, okay? And now I want to find the integration of that. So just integrate everything. Now the integration of this will just be that. Does that make sense? If you find the derivative of that, and if you integrate a derivative, essentially it just cancels each other out. So that's why it's just tan cubed x there. Now we need to find out the integration of this, okay? There's no point finding that out because the point is we want to leave it like that. So to integrate that, we have sec squared x, and that just becomes tan x, doesn't it? So this becomes 3 tan x. Now, this 3, I want you to think about as outside that integration because you can just take it out, which means that I just need to divide everything here by 3. So I have 1/3, and this just becomes 3 tan x, yeah? And now finally I apply my limits. So if this is limits from pi on 4 to 0, this limits applies here as well, okay? Can you see how it's like whatever we do to this side, we have to do to the other side in the same way as always. So now I'm just going to substitute in these limits. So I have tan cubed pi on 4, 3 tan pi on 4. Now when I substitute in 0, they're both going to equal 0. So there's just no point writing that out. Okay, so tan of pi on 4 equals to what? Equals to 1, right? And because this is the same as essentially tan pi on 4 cubed, that just becomes 1 cubed, which equals to 1. Whereas here you have 3 times 1, so equals to 3, yeah? And that just gives you 4 on 3. So you evaluated this by using the previous, okay? So over here, it says hence, you know you got to use part A. And also how you do that is you just move this to one side and then integrate everything. And all you're trying to do is essentially use this and rearrange until the left-hand side looks like this. And you work out what the right-hand side equals to by doing that.